Good afternoon, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, the Science and Technology channel.
Yeah, we're talking about our mutually favorite topic, and that is the land of space. Yep, here we go.
This is a strange one. A massive galaxy from less than 2 billion years after the Big Bang is baffling astronomers because it shows no sign of rotation. Now, the galaxies do rotate. Stars rotate around the galaxy, and galaxies rotate around a center point, the Big Bang center.
Yeah, like ours would be the sun, correct?
Right. The sun is part of the galaxy, and the sun and other stars rotate around the galaxy, and then a galaxy rotates around the center of the Big Bang, the center of the galaxy.
Okay.
Astronomers using the James Webb Space Telescope have identified an unusual galaxy from the early universe that appears to be missing something scientists expected to find: rotation. Would you like to know more?
Yeah. Researchers say galaxies are generally thought to begin spinning as they form, driven by gravity and streams of inflowing gas. But this distant galaxy, known as XMM VID1-2075, where they came up with that one, does not show signs of that motion, making it an unexpected discovery.
Okay, we're just going to call that XMM, that galaxy. The finding was described in a study published May 4th, may the 4th be with you, in Nature Astronomy. Lead author Ben Forrest, a research scientist in the Department of Physics and Astronomy at the University of California, Davis, said galaxies without noticeable rotation are usually only seen much later in cosmic history.
Current models of galaxy formation suggest that young galaxies should naturally spin as they gather matter. Over billions of years, however, repeated mergers between galaxies can disrupt or partially cancel that motion. That process is believed to take an extremely long time. Because of this, astronomers were surprised to find a galaxy with these characteristics when the universe was still less than 2 billion years old.
Maybe they need to check their variables in their model, their computer model. Nearby massive galaxies sometimes show little organized rotation and instead contain stars moving in many random directions. Scientists typically associate that behavior with galaxies that have undergone long histories of collisions and mergers.
Before using Webb, Forrest and his colleagues in the is that magazine? Oh no, not Massive Ancient Galaxies at greater than, was that near infrared?
Greater than 3.
Greater than 3 near infrared. Okay. That's a survey that had already observed XMM with the W.M. Keck Observatory in Hawaii.
These earlier observations revealed that the galaxy was already enormous for its time, containing several times as many stars as the Milky Way. The data also showed that the galaxy had largely stopped producing new stars.
Is that okay? That's where I come in. Previous magazine observations had confirmed that this one was one of the most massive galaxies in the early universe, with already several times as many stars as our Milky Way. Wow. And almost confirmed that it was no longer forming new stars, making it a compelling target for follow-up observations. That's according to Forrest.
The research team later used the James Webb Telescope to study XMM and 2 other galaxies from roughly the same era in greater detail. Webb allowed the astronomers to measure how material is moving within each galaxy.
Quote, this type of work has been done a lot with nearby galaxies because they're closer and larger than and so you can do these kinds of studies from the ground, but it's very difficult to do with high redshift galaxies because they appear a lot smaller in the sky, according to Forrest. And that's through the James Webb Telescope is really pushing the frontier for these kinds of studies. Yep, we love the James Webb.
Yeah, we do. Among the 3 galaxies examined, one showed clear rotation, another appeared more irregular, and XMM displayed random motion without overall spin. Quote, that's consistent with some of the most massive galaxies in the local universe, but it was a bit surprising to find it so early on, Forrest said.
Astronomers are now trying to determine how this galaxy became what scientists describe as a slow rotator so quickly. One explanation is that the galaxy may have experienced a major collision with another galaxy spinning in nearly the opposite direction. Such an event could have disrupted or canceled much of the system's rotation. Interesting.
Researchers believe Webb's observations may support that data. For this particular galaxy, we see a large excess of light off the side, and so that's suggestive of some other object which has come in and is interacting with the system and potentially changing its dynamics, Forrest said.
The team plans to continue searching for other galaxies like XMM in the early universe. Scientists can then compare those discoveries with computer simulations to better understand how galaxies evolved shortly after the Big Bang.
Quote, there are some simulations that predict that there will be a very small number of these non-rotating galaxies very early in the universe, but they expect them to be quite rare. And so this is one way in which we can test these simulations and really figure out how common they are. And that can then give us information about whether our theories of this evolution are correct, Forrest said.
Okay.
Way over my head how they do it.
Yeah. I mean, I'd like to know just how they came up with that identifying set of letters and numbers. What is
like a numbering system, I guess.
Yeah, I don't know. Interesting. So, yeah, interesting story.
All right, folks, thanks for joining us. We'll catch you tomorrow.
Take care, everyone. Have a great afternoon, and we'll see you in the morning.